Hi students, okay, ini adalah chapter 4 Z transform. So the outline of this, by the end of this chapter, you should be able to understand the concept of Z transform, region of convergence, types of ROC, rational Z transform, properties of Z transform, the relationship between difference equation and transfer function, and you should be able to solve for inverse Z transform. Okay, what is Z transform? Z transform is the counterpart of Laplace transform. So Laplace has been used to solve a variety of problems of resistors, inductors, capacitors in analog system using frequency domain. Similarly to Laplace transform, Z transform was also derived from the Fourier transform. And by using Z transform, you are able to simplify difference equation into algebraic equation yang you boleh guna tambah tolak darab bahagi saja, right? So Z transform is used in digital system while Laplace transform is used in analog system. So the definition of Z transform is given for a sequence of xn. The Z transform is xz. Okay, so xz equals to z xn. Okay, equals to the summation of xn times z to the power of negative n. Okay, so notation here for xn, okay, kita nak buat z transform of xn. Okay, kita letak curly bracket and you put z. Okay, equals to xz. Right, sama macam yang ni lah. Okay, now Z plane is a complex plane that consists of real and imaginary part. So Z can be expressed in a polar form. So Z equals to A plus JB equals to R exponent J omega. And if we replace Z equals to R exponent J omega, okay, so we have this new equation. And if R equals to Z, minus Z equals to 1, then Z equals to J omega, Z equals to exponent J omega. Okay, so in the complex plane, so the Z plane is represented by the x-axis, which is an imaginary plane, okay, and the y-axis is the imaginary plane and the x-axis is the real plane. So dalam Z transform, okay, you have in the Z plane you have one other thing that is called the unit circle. So unit circle is when Z is equals to 1. When Z is equal to 1, so you have then this is the unit circle. So the unit circle ni, okay, is similarly to the left hand side punya S plane. Okay, so ini antara relationship between S plane dengan Z plane, right? Now in the rational Z transform, okay, rational Z transform of LTI ataupun linear time invariant system is expressed as a ratio of two polynomials in Z to the power of negative 1. So because they are ratio, okay, this is called rational transform. Okay, so you have these two polynomials, okay, then you expand this polynomial, you get this one, right? So for yn, so for the first polynomial, yn plus a1 yn minus 1 plus a2 yn minus 2 plus an yn minus n equals to b0 xn plus b1 xn minus 1 plus bm xn minus m. Alright, so this equation bila kita tukarkan kepada Z transform, okay, so we can change this into Z transform. So for yn, okay, dia jadi yz. Okay, for a1 yn minus 1, dia jadi a1 Okay, z to the power of -1 sebab shift dia 1 and yz. Okay, then A2 z to the power of -2 because of shift ni and yz. Okay, seterusnya. And sama juga dengan B0. So for B0, xn is B0xz, B1xn minus 1. So you have B1z to the power of -1 sebab shift dia adalah -1. So you have xz. Okay, and seterusnya. Now, when we rearrange persamaan yang baru ni, so we have hz equals to yz over xz. Then you have the polynomial b di atas, then you have polynomial a di bawah. So this one is the b is referred to as zeros, okay, and the a's is called poles, right? It is called poles. Denominator is referred to as poles. So denominator as poles, nominator as zeros. And hz equals to yz over xz. If you remember from your control principles class, okay, course, this is a transfer function. Okay, a transfer function. So it shows the relationship between the output and the input. Yeah. So a rational Z transform can be written in factored form. So you boleh faktorkan balik polynomial tadi. And digital filter is designed through this persamaan. Okay. So you place the number of zeros at frequencies. You placing number of zeros at frequency of Z values to be suppressed. Yang mana kita nak suppress, kita letakkan zeros, and mana yang kita nak amplify, kita letakkan poles. Alright. So that is rational Z transform. Okay, right. Now, kita tengok lagi satu contoh ya, macam mana kita nak tukarkan difference equation kepada Z transform. Ya. Find the Z transform of the difference equation given and the transfer function of the system. Okay, so kalau kita tengok tadi, right, so for this persamaan, you have yn plus a1 yn minus 1 plus a2 yn minus 2 equals to xn. Okay, so kita buat. Alright, so kita tulis semula persamaan ni. We write the equation. So you have yn plus n minus 1 plus 2a yn minus 2 equals to xn. Okay, so the Z transform of xn, okay, xn is Z equals to yz plus z to the power of -1, shift satu lagi, yz plus a, shift 2, so z to the power -2 yz. Okay, and then if we rearrange this equation, so we have x z equals to 1 plus az to the power of -1 plus 2a. Okay, and kita letak yz. And then we arrange lagi, so you have here, okay, you have y z over x z, okay, equals to 1 over 1 plus 3z to the power of -1 plus 2A, this is Z, jangan lupa tidak buat, right, Z to the power of negative 2. So this is dia punya Z, right? Okay, so for the Z transform, quite easy, this is yang awal, right? So to find the Z transform of the difference equation, kita guna kaedah ni. Okay, don't forget dia punya delay ni is dependent on delay yang dalam ni, alright? So then you have this. Okay, now ini yang cantik lah. Okay. Now what is ROC? Dalam pole zero plot, okay, tadi kita tahu dah the nominator is the 0 and the denominator is pole. So in the Z plane, the location of each pole is indicated by X and the location of 0 is indicated by 0. Alright, so ROC is indicated by shading the appropriate region of Z plane. So in the when we plot the pole zero plot, okay, you have the Z plane, okay, and for each pole, okay, you tandakan dengan X, right? So in this example, the X is the pole is A, okay, pole adalah A, and it's it's marked by X. Alright, so the X ni, okay, so the pole is okay, pole is Z is, so dekat sini, right, so you buat dalam bentuk annular region, dalam bentuk cincin. Okay, so you plot around in a circle. Okay, so dekat sini, if katakan you punya ROC adalah Z is bigger than A, okay, bigger than A, so maknanya you punya shaded region ni dekat luar A, dekat luar A, right? So this is shaded region. Now this is for filter yang FIR, kita pakai hanya ada zeros saja. IRR ada zeros and poles. For rational HZ, the ROC contains no poles but bounded by dia punya poles. Dalam ROC ni sendiri patutnya tidak ada poles, dia tidak ada poles, dia bounded by poles. Okay. Now types of ROC, ada ROC yang berada di dalam region, dalam bulatan, ada ROC yang di luar kawasan bulatan ini, and ada yang dalam bentuk ring ataupun donut shape. Okay, so or it's called as annular region. Okay, now the ROC of a rational Z transform cannot contain any poles. Okay, cannot contain any poles and is bounded by poles. Okay, for a right-sided sequence, the ROC is outside of the largest pole. So means dekat sini, kalau kata you ada dua pole, okay, and then pole yang paling besar adalah beta ni, and then ROC dia adalah luar beta, okay, luar ni. So then this is a right-sided sequence. For a left-sided sequence, the ROC is inside the smallest pole. Okay, inside of the smallest pole. So means, okay, alpha is the smallest pole. So di dalam region. Okay, so this is a left-sided sequence. For a two-sided sequence pula, so tadi left-sided, okay, and this is two-sided sequence. Okay, two-sided sequence. Some of the poles contribute to the terms in the parent sequence of n smaller than 0 and other terms n larger than 0. Therefore, the ROC is between the circular region outside of the largest pole coming from the n bigger than 0 sequence and inside of the smallest pole coming from n smaller than 0. Okay, so means that dekat sini bila you ada dua poles, okay, you punya ROC can be either of these three region, yeah. So means that kat sini this is right-sided sequence, this is left-sided sequence, and this is two-sided sequence, two-sided sequence. Alright, so uh, tengok dia nak tahu kita kena tengok daripada different equation. Okay, so if ROC tadi, shaded region tadi, bahagian yang di lorik mengandungi unit circle, includes the unit circle, then the Fourier transform of the sequence converge. Converge tu dia boleh di compute lah, okay, boleh di compute, and Z transform is stable. Otherwise, the Fourier transform diverge, okay, and the Z transform is not stable. Okay, so means that unit circle tadi satu kan. Okay, so unit circle tu mesti dalam ni punya ROC. Okay, ni kiranya ni ROC, contoh ROC for apa ni, ring type kan. Ring type, so dekat sini ni ring type, so dekat sini is ya. So dekat sini ring type, ya, for ring type katakan antara dalam ni, dalam region ni. So kalau katakan kalau dalam apa ni, inward tadi tu, so dalam bentuk inward, so inward, okay, so you have inward, so kawasan lorik ni di dalam circle, so unit circle tu mesti ada di dalam dalam circle tu. So tadi kalau dalam outward tu dia dekat luar, lorikan dia di luar, so means that dia punya unit circle mesti di luar. Okay, alright, so this is apalah the description for this one. Now kita tengok satu lagi contoh yang macam mana kita punya macam mana kita nak tahu bentuk ROC. Okay, so let's consider a signal that is the sum of two real exponentials. Okay, so diberikan xn equals to persamaan yang ini. Okay, right, the Z transform, kita ingat tadi definition of Z transform is that xn is equals to xz dan dia diberi oleh summation yang ini, ya. Okay, so kita tukarkan. Okay, so we put the we translate the xn into dalam persamaan ni, gantikan, ya. So gantikan xn ke dalam masukkan xn ke dalam persamaan ni. So you have this, okay, yang ni tadi xn, okay, xn, and then kita kembangkan, so you have persamaan yang ini. Alright, now from here kita kena kembangkan lagi using geometry series. Okay, geometry series dia definekan summation of alpha to the exponent k is equal to 1 over 1 minus alpha. So daripada sini kita boleh kembangkan persamaan dan ini guna formula ni. So you have this one defined as this, and this is, and kalau kita nak kembangkan lagi, you have your persamaan. But usually we stop at here. Okay, we stop here for the ROC. Continue here if kita nak buat transfer function. Okay, so untuk ROC kita tengok yang bahagian pertama ni dulu. Okay, the ROC will be the intersection of individual regions of convergence, iaitu the values of the Z for which both individual sum converge. So means that kita tengok satu-satu persamaan. So kita tahu tadi ROC is daripada poles. Okay. So poles is bahagian denominator. Okay, bahagian denominator. So kita tengok denominator dia ada dua. Okay, sorry, denominator bahagian bawah ni and poles ada dua. So we look term by term. Okay, so pole zero plot and ROC for individual terms and sum of terms. So kita tengok yang pertama dulu. Yang pertama tadi, so we have poles here. So kita lukiskan Z plane. Okay, so you lukiskan punya Y axis, X axis dengan unit circle. Okay, so this is, and then kita tengok bahawa dia punya Z ataupun pole dia adalah 1/2. So this is 1/2. So lukiskan yang ni. Alright. Now the next one, kita pada term yang seterusnya, iaitu 1/, term yang kedua ni, and we see that again you look, so on the same plane tadi ni. Okay, so kita ada pole yang ini. Now kita lukis the second pole, which is 1/3. Okay, so this is yang lukisan yang ni. Now you have this figure. Okay, you have Y axis, you have your X axis, you have your unit circle. Okay, unit circle, and then you have your first pole and second pole. Now if we say that, okay, if we say that the first region, for the first pole, okay, katakanlah semua ni right-sided sequence, right-sided sequence, so means that dia punya lorekan tu mesti luar daripada circle atau luar daripada pole. So we say that Z is bigger than 1/2. So lorekan dia di luar pole. Okay, di luar pole 1/2 ni lah. Okay, yang dah lorek ni. And then for the second term pula, kita kata pun sama. Z is bigger than 1/3. So kita lorek juga di luar 1/3. Now, where is your ROC? Okay, so dekat sini you dah lorek 1/2. Okay kan? Dan dekat ni 1/, ni, this is lorekan 1/2. Okay, nak bagi nampak ni 1/2. Okay, dan 1/3 pun lorek kat luar 1/3 ni. Okay, so kita lorek kat luar ni. 1/3. I'm trying to do this. 1/3. Yang dia shaded to bertimpa. Okay, so dia bertimpa di kawasan luar 1/2. Okay, kawasan 1/2. Sebab dekat ni dia kalau kita tengok tadi, okay, ROC will be the intersection, will be the intersection of individual regions. Okay, intersection tu maksudnya dia kena bertimpa lah. Okay, so means that yang bertimpa adalah di luar 1/2. Okay, so that therefore you punya ROC adalah 1/2. Okay, dekat maksudnya akhirnya adalah di 1/2. Saya tak buat pula side kat sini. 1/2. Okay, so in summary, okay, so kalau you ada satu for a relationship between ROC and time axis of signal, right-sided signal has ROC of in the form of Z bigger than poles, and left-sided sequence dia adalah lebih kecil, and two-sided sequence adalah in between. Now, so tadi masa kita nak buat nak tukarkan pada difference equation kepada Z transform, we use this formula. Okay, that is also where you can use table. So kita ada Z transform pair. Okay, so tadi UN lebih kurang macam ni. So you tukar kepada 1 over 1 minus Z to the power negative 1 ataupun yang ini tadi. Okay, this one. So kita boleh tengok pada table saja, and this is given in the index, in the appendix. Okay, so for that kita berhenti dekat sini dulu. So basically that is Z transform, and I will give you more examples later on. Alright, thank you.